Okay, this is example 4, the last example for 10-6, using the quadratic formula. We're learning how to choose an appropriate method. So we saw on the last slide all these different methods to use, and as I was looking at it, I think really we're just going to leave out completing the square. It's an overly complicated method to solving a quadratic formula, and really using the quadratic formula is much easier. So we're just going to leave this out altogether. You're not going to have to deal with it, and you should be grateful. So let's look at A. We want to know what would be the easiest way. Remember, when in doubt, the quadratic formula will always work, but it takes some time. So if it's an easily factorable equation, then you want to factor it to solve, because usually that's a little shorter. So looking at this, we could try grouping 5 times negative 14, which is negative 70, and finding the factors of negative 70 that add to be 8. So we want to multiply a negative times a positive, with the positive number being bigger. Obviously, negative 1 and 70 isn't going to work. Negative 2 and 35 won't work. 3 doesn't work. I don't think 4 doesn't work, but we can do 70 divided by 5. So negative 5 and 14. Now that gets us close. We're 1 off with that. We're at 9, but we got to be right on. So if you try 6, that doesn't work. 70 divided by 7 is 10, so negative 7 and 10. And then really we're getting further away. That's a 3. So you can see once you try, you can't factor it because you won't find those two numbers that you can use to rewrite this. So you can't factor it. And since it's not easily factorable, then you just go ahead and use the quadratic formula. So what method? Quadratic formula, and then we need to justify it. We're using it because the equation can't be easily factored. All right, let's look at another one. So this one, since it has no x term, you definitely want to try using square roots. So let's practice that again, since we skipped that section. But all you're doing is solving for x. Remember, your whole goal is to find what x is. When they ask you to solve, what they're asking for are your x-intercepts, and therefore you're simply solving for x. So let's do that. How would you get x squared, or x alone? Well, first move 169 to the other side. So add 169 to both sides. Actually, there's more than one way to do this, but I think this is the method you're probably more used to using. So we have 25x squared equals 169. Then divide both sides by 25, so that x squared equals, let's see, what is 169 divided by 25? 6.76. And then square root both sides. Remember, the opposite of squaring is square rooting, and with algebra we're always undoing operations. Like here, since it was minus 169, we added it. Since it was 25 times x squared, we divided by 25. So since x squared, square root, we're always undoing operations. So x is plus or minus. Very important, because that means you have two answers. Very, very important that you put the plus or minus. The square root of 6.76 is 2.6. And we put these because it could be a positive 2.6 or a negative 2.6. Since negative 2.6 times negative 2.6 will still give you a positive 6.76. So here's your answer. And yeah, square roots was easy. You could have used the quadratic formula, but it would have taken you a whole lot longer to come to that answer. All right, on C. This looks like it would be easily factorable, so let's check it out and see if it is. Since there's no coefficient to your x squared term, you just do the factors of the last term that add to be the middle term. We need a negative times a positive to get a negative. Negative 3 and positive 1 add to be negative 2, definitely. Very easily factorable. So how would we do this? Factoring. The equation is easily factorable. We just saw that. It'd be really easy to factor it. If you remember from here to solve it, we would have, we factor it, so x minus 3 times x plus 1 equals 0. Split it up, x minus 3 equals 0, or x plus 1 equals 0, and then solve each one. Add 3 to both sides, x is 3, or subtract 1 from both sides, x is negative 1. So yeah, very easy to solve. Okay, on this one, I'd look at it and I think, let me try to factor. So factors of the last term that add to be the middle term. And we're not going to come up with anything. So we'd multiply two negatives, -1 and -3, but that only gets us to -4. It's not going to work. So we can't factor it. So right here I would just say, go ahead and use the quadratic formula. You could also graph it. But we don't know how easy it'd be to point out the x-intercept. So just go ahead and use the quadratic formula because it's not easily factored. Basically, if you can't factor it or use square roots, go for the quadratic formula. All right, looking at this one, the numbers are huge. It might be factorable, but these numbers are so big, I really don't want to sit here and try and find all those different factors. So when your numbers are this big, go ahead and just use the quadratic formula. Quadratic formula. And your reason can just be that the numbers are large and the equation is not easily factored. All right, let's look at one more. So here's another one that you could use the square roots method, and actually they're almost there for you. Divide both sides by 144. Just trying to solve for x. Our whole goal is to solve for x. So what's 25 divided by 144? Obviously a decimal, and actually it's kind of a crazy decimal. 0.7 or 0.1736111111, etc. Square root both sides. So in your calculator, I would do, and remember it's always plus or minus, I would do second square root, second answer. And answer is above the negative, so you end up with 0.41666, etc. And then you always want to check and see if you can turn it into a fraction. So I just hit math, enter, and x was plus or minus 5/12 is the fraction. So positive 5/12 or a negative 5/12. Okay, let's look at this one. I'm looking, there's no coefficient to x squared, so let's see if I can factor it. The factors of the last term that add to be the middle term. Negative times a positive, but the only factors of 13 are 1 and 13. So not getting a 2. That's not happening. So for this one, I'd say, well, it's not easily factorable, so just go ahead and use the quadratic formula. On this one, since it's not easily factorable. All right, and then in class, I may show you how to use your graphing calculator to graph a quadratic formula or graph a quadratic function on there, maybe this one even, and show you how to find the x-intercepts that way, because your calculator will tell you what the exact x-intercepts are. But you can really only use that if you have a graphing calculator handy. Okay, so that's it for this lesson 10.6, last one for chapter 10, and we're almost done.